Okay, so good morning to everyone. Today we are going to learn a new way of thinking, and this is called the system thinking. So, system thinking helps us understand why problems happen and how different things are connected. So, instead of looking at only one small problem or a portion of it, we will try to say the whole system. So, all throughout the lecture that I will be giving today will be all about or elements of a system thinking. So, we will be starting with the iceberg model, which is like the philosophy of the system thinking. Also, with the behavior over time graph or BOT and causal loop diagram or CLD, which is the blueprint of system thinking, and BOT is the storyline of the system thinking. And then I would like to add as well the connection circle. I think this is very important aspect in preparing CLT. So these are the things that we will be looking at in this lecture. So let's go to the iceberg model system thinking. So I don't know if you've seen or if you can remember an iceberg, probably in the movie Titanic. But an iceberg is a massive block of ice floating in the ocean. But I think we are all aware why iceberg is something very interesting because only a small part of the iceberg is above the water and much bigger part is hidden under the water. So problem in life are like an iceberg. So it has level. As you can see, it has in this illustration, it is segmented into four, starting with the events and then patterns and trends, which is already submerged, the structure, and then lastly is the mental models. Let's start with the level one, and this is the events. This is the visible or what we see. Events are things that happen that we can easily see. So, example, there is a lot of trash or rubbish in the river. We can see that. Or students that are failing the test or failed a test, or a flood happen. But events only tell us what happened, not why it happened. So that is in the level one of the iceberg model, which is called events. Next, the level two is the pattern and trend. In here, it tells us what trends are there over time. So patterns ask the question, does this problem happen again and again? So example, the river has trash every week. So you see there is a kind of a trend on that statement. Or students fail the same test every year. So it's repeating. Or floods happen every rainy season. So patterns show us what keeps repeating over time. Next level is the structure in here. So in the structure, it means how things in the system are connected. So example, maybe the trash problem happens because people throw garbage in the canals. Yeah, you can see there. We are trying now to connect items in the system. Second, maybe there are not enough trash bins, as also can be why we have the trash problem, or the trash problem happens because waste collection is irregular. So you can see in here, structure explains how the system works in that level. And lastly is the level 4, which is commonly invisible. And these are about the values, the beliefs, and shape the system, which is the deepest part of the iceberg. So, mental models are beliefs or ideas people have. So, example, some people may believe throwing one piece of trash does not matter, or someone else will clean it. You know, if but if many people think this way, the problem becomes bigger. In Phuket, Thailand, they have a very good incineration for plastics. So if you will go to Phuket, Thailand, they actually have a very good waste management in that place. However, people are aware of the incineration. They know that government collects their rubbish and then process it, and then later on it becomes water or soil being recycled well. So the mentality of Thai people in Phuket is it's okay then to use plastics as much as we can. Anyway, the government will collect our plastics and they will do something else and make it um, something that is very, that they make rubbish out of rubbish, they make something that is useful. That's the mentality of people in Phuket. So if you go to their groceries, it's plastics over plastics. They really use lots of plastics in that place. But of course, that's really true that they have very good incineration for plastics. However, they also did not realize that not all plastics goes to the incineration. Some of them actually ends up into the beach and other places in Phuket. Of course, there will still be use of fuel there when they are collecting, perhaps, and the other machineries in the incineration. So they don't consider that. They just see things like the government is doing this, so I can do this. Something like that. I don't know if that's making sense. But that's how I give, analyze, or maybe example related to about values and beliefs that shape the system. So remember that events what we see. A pattern is what repeats over time. Structure is how things are connected, and mental models what people believe. So this is the philosophy of system thinking. Now let's go to BOT, or the behavior over time graph. So this is how things change over time. So instead of asking what happened today, we ask how did it change over time? So, for example, imagine we track plastic waste in our school. So maybe it looks like this, like January little plastic, February, more plastic, and then March, even more plastic. So this means the problem is increasing over time. A BOT graph helps us see the pattern of change. Another example is when you're tracking your finance, maybe if you will put it in a graph, if you see that the line is actually going down. So from the past 6 months, the past maybe year, it's growing, it's increasing, and then in the past 3 months, it starts to go down. So you can see there is a problem with maybe the finance, your budgeting, or you see the change over time about your money. So we can see that with BOT because BOT is the behavior over time. It could also be with this diagram that I use in this presentation, wherein the x-axis is the time or year, and then the y-axis is the population or the people. So we can see in here that there is actually an increase of population in from 0 to 50 years. Okay, so let's define then the BOT. So BOT shows us how a variable changes over time. So key features, x-axis is the time, y-axis is variable being observed, and it shows us trends or pattern. Purpose to observe patterns, growth, decline, or oscillation, or stability. So it helps identify what is happening in a system. For example, are this. In simple terms, BOT answers what is happening over time. Moving on, the CLD or the um, causal loop diagram. Okay, so these diagrams show us the feedback loops that you can see in the workbook. So in the workbook, you will actually see examples there, explanation, definitions, descriptions of these loops. Now, a feedback loop means things keep influencing each other in a cycle. So, our example about more trash related or connected to more pollution, and then connected to people complain, connected to government cleans the river, and then connected to the trash decreases. So this is how system works. Everything is connected. So um it's either, as you can see in here, reinforcing, that means it keeps on increasing, or it's balancing, wherein from time you will see some deduction or negations or negative um, negative feedback loop where it tries to bring it into a usual or normal or equilibrium. Okay, so let's define CLT. CLT shows relationships between variables in a system. So key features, arrows showing cause and effect relationship, and positive relationship variables move in the same direction. Negative variables move in the opposite direction. So feedback loops, as I mentioned a while ago, if it is R or reinforcing loop, it amplifies change. Balancing loop is stabilizes the system. Hmm? Purpose of CLD to understand why something happens and to identify feedback loops and system structure. And these are the examples. In simple terms, CLD answers why is it happening. Okay, so this one is a very good summary of the BOT CLD in terms of their features comparison. Okay. Um, Okay, let's go now to the connection circle. I believe this is not in the textbook, but connection circles is how we can see how things are connected. So we use something like this um, to see the connection of the variables. So as you can see in this illustration, we write the variables around the circle, and then we start to find out their connections using arrows. And hopefully, as we continue to do that, you will find some loop. And from that loop, you can start your CLD. And from the CLD, you can start your BOT. So this one is an example of a problem um, referred as the Operation Cat Drop. In the late 1950s, WHO tried to eradicate malaria-causing mosquitoes in Borneo by spraying the village areas with DDT. Soon, the palm thatched roofs of the village houses began to collapse. The predatory fly that ate a palm eating moth larva, which fed on the palm fronds, had been annihilated by the DDT. The dead DDT contaminated flies were eaten by lizards that were then eaten by house cats, which also died. Soon the disease carrying rats began to invade the dwellings. To solve the problem, WHO dropped cats into the villages by parachute. So in the article, we need to identify the variables. The variables need to be or should be changing over time. So you need to take note of that. Variables needs to change over time. And if we identify that these are the malaria, mosquitoes, DDT, predatory fly, lizards, house cats, and rats. These are just 1, 2, 3, 4, 5, 6, 7, 8. So this is still good and is actually still manageable. 8 to 10. More than 10, it will look, if you have more than 10 variables, I find it so hard to, well, you still can do it, but it's challenging because your arrows will be very crowded already around your circles. Sometimes when I do the arrows, I also use different colors depending on the variables. So I know that this arrow is coming from here, coming from there. Because if they are all black or if they are all in the same color, it's confusing. It's confusing to track. So I put those in around the circle, and then I'll start to identify their connection. So as you can see, actually in here, you can, we made a loop. We made a loop out of the malaria, DDT, and environment, and mosquito. So out of that, you can start making your loop, your CLD. So from the malaria, DDT, mosquitoes, I mean, they're trying to eradicate mosquitoes. But what happened, we know that instead of, um, you know, decreasing the malaria, it's actually brought more disease through the rats there. So, oops. All right. So there, just for key ideas, one more time for system thinking. The most important lesson is this. If we only fix the event, the problem may come back. But if we understand the system, we can solve the problem better. But if we, and so system thinking helps us, the system thinking helps us ask what is happening, what patterns do we see, how things are connected, and what beliefs are causing the problem. When we ask these questions, we become better problem solvers, hopefully. And from there, if you have any questions, you can send me a message, or Mom Che, or Sir Marlon, or the other professors. Thank you very much, and goodbye.